All right, group. So this is the second video for last week. This is a hypothesis test for the difference of population proportions. When you look at this, if you notice, I do have the Excel program for you, and I did call it difference of population proportions. It's the last tab in the bottom. What I want you to do is to pay note or attention to the fact that I'm asking you to only change the orange cells. They're right here. You can see them. Basically the p hat 1, p hat 2, that's the only thing I'm asking you to change. And in this example, if you notice, the reason why I'm bringing that to your attention is in this question, it says something about 66 couples. If you notice right here, there's a random sample of 66 couples, of which 46, according to this, had visited a miniature golf course, and a second group or a second proportion selected of 65, of which 41 had visited a miniature golf course. So if you notice that these are the proportions I have here, I would call this, if I were you, p hat 1. So I'll just write the 1 in. I'm going to send this to you. And this is p hat 2. And this is the only thing you need to input in here. Everything else, if you notice, is all centered around this. It's all been calculated for you. So for example, the pooled p hat, which is 0.66, is the result of this formula. Let me pull this out here. It looks just like this. And it did the same thing for you for pooled q hat, which is basically 1 minus p hat. So I can open this up a little bit. As far as the sample size in the formula, there's a 1 over n1 and 1 over n2, which I did right here. So if you notice, that is simply 1 over a5. Again, you don't touch this. 1 over this one I have to also program. So if I did a5, then this will be f5. So that way it'll take the formula. Oops. E5 is what this should be. Okay, wonderful. So I'm just going to show you real quick with this example that you have your test statistic listed for you right here. Let me give this color. Let's go with blue so it sticks out. That's your test statistic. You will also notice that I'm asking you, notice that you get 0.802 when you do the calculation. I'm asking you to round down to 0.800. I then have programmed the p-value. So if you look here, you're going to have to, once you put in the 0.800, like this, I will change, if I were you, to 0.800, and this is going to take that information. So technically, I'm going to change this one more time because I backed up and changed it myself, but I changed a part of it. It was numerically. See how it jumps to 709? So if you need to change that, maybe make this the default. And just instead of this, you're going to do equals norm as dist. And then what we'll do is we'll come over here and just select the default. Okay, I'll make the default green as it's pretty close to blue, if that works for you. So yeah, you may get a different number, but you're going to try to round it closely to numerically what makes sense. So we'll call this the default, and I'll even write it down for you. That's when you get the answer incorrect, and it's correct based on your calculations. So in this part of the discussion, it says state the null and alternative hypothesis. So basically, you're going to come over here, and let me go through this way since it's not letting me click it in. So according to this question, it's definitely equal to, not equal to kind of situation. in the questions, they just want to know if there's a difference. So you would do P1 minus P2 equals 0 for the null hypothesis. And for the alternative hypothesis, you're simply going to say P1 minus P2 does not equal 0. Part B is what I did for you in the Excel sheet. It basically is all of this information. And you don't need to do all that. You just need to change the orange cells, which are the p hat 1 and p hat 2. So you notice they do get 0.800. And then looking at norm as this, if you notice it's two-tailed. So this is the value down here for two-tailed test. If it's not two-tailed, this is what you would use. This is one-tailed, and this is the area above. This is one-tailed area below. So just remember these two are one-tailed. All right, you can see it up here. If you can't see it down here clearly, you can at least see it up there. And then remember, the rule of thumb is always that if p value is greater than alpha, we're going to reject the null. And so p value is very high. I think we're likely to fail to reject a null. So can we conclude that the proportion of couples visiting the miniature golf course is different? We would say no. Okay? All right, so having shown you this example, which I wanted to just share with you, you can pause this as you need. And again, here's the original question. And they specifically ask you for a two-tailed test. What I want to do is I want to go ahead and go to try another. And let's see, I want to test my theory that this actually works. So let's try another. Okay. And so pay attention to the wording. Look at what it says. And this is the only one that's kind of tricky with respect to the rounding on the z-score. So be careful with that. So let's look at this together. A miniature golf course was recently added at the fairgrounds in a U.S. state. To see what sorts of people are visiting this new attraction, a survey was done at this year's state fair. It was found that among a random sample, here we go, random sample of 65 couples, right here, at the fair with their children, 36 had visited a miniature golf course. Okay, so we're going to come over here, and this is now 36 over 65. All right, notice that I'm going straight to the other orange cell, where it says a random sample of 70 couples at the fair without children, and 28 of them had visited a miniature golf course. So here we are. And that's all you need to do. All right, so you can see your test statistic is 1.79. According to this should be your p-value. Let's see what's going on here. This seems like it didn't change, because I'm still at B14. I don't know why. B14. Yeah. Okay, so this is now registering at the other value. Let's see what they are doing here. They want us to perform a two-tailed test. So this is two-tailed as well. So I'm just going to put in here 1.789. And let's see what happens, because I'm curious. I would just want to make sure I just programmed this for you guys. Okay, so we do have our p-value upper area. It's equal to, not equal to. So let me see if I can actually put this in here. So in essence, we are selecting p hat 1 is equal to p hat 2. I'm going to go p hat and put a 2 here. Go back to this one and have to select the little thing here. Yes, I want p hat 1. So p hat 1, I don't want an equal to, I actually want minus p hat 2 is equal to 0. And then over here, and this is the next one, I want p hat 1 minus p hat 2. So p hat 1 minus p hat 2. So I'm actually going to do this, and I want not equal to 0. Okay? Obviously, this is going to be a z-test. And find the test statistic. They want 3 or more, so I'll go with 1.789. And according to this, they're asking us for a critical value of 0.01. So technically, I'm going to say inverse equals, actually norm S inverse. And I'm going to put in the low end 0.005 because that's half of 0.01. This is just a plus and minus of those two values. So I'm going to put in negative 2.576, and the upper side I'm going to do the positive 2.576. And now remember, the rule of thumb is if OV is greater than CV, we are going to reject the null. You can also still look at the p-value. You got a two-tailed p-value of 0.074. So p less than alpha, we're going to reject the null. OV greater than CV, we're going to reject the null. So if I'm saying that, can we conclude that it's different? I would say yes, because it looks like the OV is greater than the CV. Okay, so if you notice, everything is there for you. The 1.789, which is our test statistic, your inverse norm, you're going to have to solve for. And that's right here. So if I double click on it, you can see up here in the tab, it shows very clearly. And that's all you need for this one. This one should not be that bad. Let's check it and make sure that we are good on the rounding. Okay, so it's telling me something's off. The answer is incorrect according to this. Did I say reject or no? OV is greater than CV. OV is greater than CV. No, OV is less than CV. Oh my goodness. I cannot believe I made that mistake. I'm glad I did though. So observed value, I literally read it backwards, is 1.789. The critical value, which is your value that you just looked up, CV, that is definitely 2.576. So if the OV is greater than the CV, which it's not, right? In this case, we are less than, we're going to reject the null. All right. If the OV is greater than the CV, we're going to reject null. So in this case, we're going to fail to reject the null. So no. Yeah. Okay, let's see what's the matter with this part. It could just be how I located. Okay, let's change this then. I'm going to change this variable to P. I don't think that's correct, but okay, I'll try it and play devil's advocate. So let's see here. Let's see here what happens when I change this. Maybe that's the only thing that I need to change. I was pretty confident that all we needed was the p hat. So let's recheck and see what happens. Yeah, that's what it was. They didn't want p hat, they wanted just a p. That's it. That's the only difference, though. If you'd like, let me do another just to try. Let's try another one, just for funsies. So again, you notice that the only thing I'm changing in either of these, you're going to see me do this again, is the orange cells. So based on advancements in drug therapy, a pharmaceutical company is developing Recithium, a new treatment for depression. A medical researcher for the company is studying the effectiveness of this drug, Recithium. Exemor, they're comparing it to Exemor. I'm sorry, I'm speed reading. And okay, a random sample of 521. So this is 521. Is selected and treated with Recithium. 268 found relief. So these are the people that found relief, which is 268. Remember, there's always the opposite, which are the people who did not find relief, which is your Q hat. All right. Instead, a random sample of 581. So they have another sample of 581. They were selected, and 283 of these people found relief. So there's everything we need. Okay, once again, remember that this can be rounded to 0.900. I would debate 910. I'm going to go with 910. What do you think about the test statistic? So we're going to round it. Okay, so that's just a note. All right, so we'll go with that. So our default is going to equal this number rounded. All right, so let's talk about what's going on. It says, based on the medical researcher's study, can we conclude at the 0.01 level of significance that the proportion 1 of all depressed individuals taking Recithium who find relief from depression is greater than proportion 2. Okay, so we start with proportion 1 is equal to proportion 2. I'm not going to change that because I think that is accurate. In this case, this is equal to 0. I'm almost tempted to do this a little differently just for funsies. Let's try this. We'll leave it at P1 equals P2 since this said greater than, right? So according to this, we will label proportion 1 Recithium. So that'll be our P1. And I'm going to go with is greater than, right? P2. Let's see if it likes this notation. I'm curious. Why not try it while we're in a safe space, right? Let me go back. Greater than. Oh, something's wrong there. There we go. You may have the same issue. I'm glad that happened as well. You notice I pushed over and then I hit it again and it gave me the correct notation. So be patient. All right, let's go with that. Let's see what happens. Yes, it's a z-test. Okay, lovely. The test statistic according to this is right here. The z-test statistic is 0.9. I'm going to go with 0.91 just to try it, not 905. And then it's one-tailed in this case, so can we go with 0.819? 0.819 because they said greater than, so 0.181. 181. So if P is less than alpha, so let's go with the P value this time. I'm actually going to delete this because I don't want to confuse anyone. So P value alpha, according to this, our alpha is 0.01 and it is one tail, so I don't have to mess with it. The P value that I'm obtaining here greater than is 0.181. This is the area above because it's greater than, right? So If P is less than alpha, we're going to reject a null. P is less than alpha. We will reject a null. P is not less than alpha. It's actually greater than alpha. We're going to fail to reject a null. So if I fail to reject a null, then no. All right. I'm going to see how it responds to this notation up here and how it responds to the C answer in part C, because I went ahead and rendered it. Perfectly content. So this works. All right, remember that's a no for an answer, and there's your... All right, well, that's what I have for you for part 2. All right, have a good rest of your week.